Beyond our blue planet, floating in the vast darkness of space, is a world that might just harbor the greatest secret in our solar system. It's not a distant exoplanet, but a moon orbiting the gas giant Jupiter. Its name is Europa, and beneath its icy, cracked surface lies an ocean, a hidden world that could potentially be home to life. For decades, we've looked to Mars, the red planet, as our best bet for finding extraterrestrial life. But what if we've been looking in the wrong place? Europa presents a tantalizingly different possibility. Imagine a global ocean, twice the volume of all of Earth's oceans combined, completely encased in a shell of ice miles thick. This isn't science fiction, it's what scientists believe exists on Europa right now. The story of Europa begins with the Voyager and Galileo missions. These robotic explorers flew past Jupiter and its moons, sending back images that changed our understanding of the outer solar system forever. They showed us a surface on Europa unlike any other. It was bright, incredibly smooth in some places, but crisscrossed by a chaotic web of dark, reddish-brown lines and cracks. Scientists looked at this and thought, this looks like sea ice on Earth. The cracks, ridges, and jumbled blocks of ice, called chaos terrain, suggested that the icy shell isn't static. It's moving, breaking, and reforming. And what could cause such dynamic activity? A vast, liquid water ocean flowing beneath it. But how can a moon so far from the sun, where surface temperatures plummet to minus 160 degrees Celsius, have a liquid ocean? The answer is gravity. Europa is caught in a gravitational tug-of-war between the colossal Jupiter and its other large moons. This constant stretching and squeezing generates immense tidal forces, creating friction and heat deep within Europa's core. This internal heat is enough to keep the water beneath the ice shell from freezing solid, creating a stable, liquid environment that has likely existed for billions of years. So, we have a massive, long-lived ocean. That's step one for life as we know it. But water alone isn't enough. Life needs three key ingredients: liquid water, essential chemical elements, and a source of energy. We've established the water. What about the other two? Let's talk about the chemistry. The reddish-brown material we see staining Europa's cracks is believed to be salts and sulfur compounds, churned up from the ocean below and irradiated by Jupiter's intense radiation. This tells us that the ocean isn't just pure water, it's a salty, chemical-rich soup. Furthermore, scientists believe that Europa's ocean floor is in direct contact with its rocky mantle, just like on Earth. This is a crucial point. Here, on our own planet, we have hydrothermal vents on the ocean floor. These are volcanic hotspots that spew out superheated, mineral-rich water, creating oases of life that thrive in complete darkness, independent of the sun. Could similar hydrothermal vents exist on Europa's seafloor? It's a very real possibility. These vents could provide the necessary chemical building blocks for life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, and the energy to assemble them into complex organic molecules. This brings us to the final ingredient: energy. Life on Earth is largely powered by the sun through photosynthesis. But deep in our oceans, life flourishes without sunlight, using a process called chemosynthesis. Microbes at the base of the food chain harness chemical energy from the reactions happening at hydrothermal vents. If these vents exist on Europa, they could power an entire ecosystem, completely independent of the sun, hidden beneath miles of ice. So what kind of life could we imagine? We're probably not talking about intelligent, complex creatures. Instead, astrobiologists speculate about microbial life, similar to the bacteria and archaea found in Earth's harshest environments: the deep-sea vents, the subglacial lakes of Antarctica, or highly saline waters. These extremophiles, as we call them, have shown us that life is incredibly resilient and can adapt to conditions we once thought were impossible. Perhaps on Europa, over billions of years, this microbial life could have evolved into more complex forms. Maybe there are worm-like creatures, or even small fish-like organisms navigating the dark, nutrient-rich plumes of the hydrothermal vents. It's speculative, but not outside the realm of possibility. One of the most exciting recent discoveries comes from the Hubble Space Telescope. Hubble has detected evidence of what appear to be plumes of water vapor erupting from Europa's surface. shooting hundreds of kilometers into space. Imagine geysers, like Old Faithful in Yellowstone, but blasting through an ice shell and venting ocean water directly into the cosmos. These plumes are a game-changer. Why? Because they offer us a way to sample Europa's ocean without ever having to drill through its incredibly thick ice shell, a massive engineering challenge. This is where upcoming missions get really exciting. NASA's Europa Clipper mission, set to launch soon, is designed specifically to investigate Europa's habitability. It won't land, but it will perform dozens of close flybys, getting as close as 25 kilometers from the surface. Clipper will use a suite of powerful instruments: ice-penetrating radar to measure the thickness of the shell, a magnetometer to confirm the ocean's depth and salinity, and spectrometers to analyze the composition of the surface and any potential plumes it might fly through. If Clipper can fly through one of these plumes, it could directly analyze the chemistry of the ocean below. It could search for organic molecules, the building blocks of life. This mission won't be able to detect life directly, but it will tell us if Europa has all the right ingredients. Following Clipper, the European Space Agency is sending its own mission called JUICE, the Jupiter Icy Moons Explorer. While its focus is broader, studying Jupiter and its three largest icy moons, Ganymede, Callisto, and Europa, it will also perform crucial flybys of Europa, adding to our knowledge and helping us piece together the puzzle. The ultimate dream, of course, is a lander. A future mission that would actually touch down on the icy surface, perhaps near an active plume or a crack, and use sophisticated instruments to search for biosignatures, direct evidence of past or present life. Imagine a probe melting its way through the ice, a cryobot slowly descending into the dark ocean below, lights blazing, cameras rolling, searching for the first glimpse of another living world. The prospect of finding life on Europa is profound. If we discover life there, and if that life arose independently from life on Earth, it would mean that life is not a unique accident. It would suggest that life might be common throughout the universe, emerging wherever the conditions are right. It would fundamentally change our place in the cosmos. We would no longer be alone. Europa is more than just a moon. It's a beacon of hope in our search for life beyond Earth. It's an ocean world, locked in ice, holding a secret that we are on the very cusp of unveiling. The journey to Europa is a journey to answer one of humanity's oldest and most fundamental questions. Are we alone? And the answer might be waiting for us, in the cold, dark depths of an alien ocean, just one planet over. Thanks for joining me on this incredible journey to the ocean world of Europa. If you're as excited as I am about what we might find, make sure to like this video and subscribe for more explorations into the mysteries of our universe. What do you think we'll find beneath the ice? Let me know in the comments below. See you next time.